Okay, so today we'll just go over the basics of volume. We actually don't have too much to talk about here, a couple of pages of notes. So does anyone know, like, how can we define volume? Like, what exactly is the volume of an object? Where are you from, Tyler?
How much space it takes up?
Good, that's the definition we're going to use. The volume is how much space an object takes up. All matter has mass and volume. Takes up space and has mass. So we are going, what's up? No, you don't tell me. So we are going to talk about a couple, we're going to have to measure in lab volume of solids and liquids, not really gases. So we have two different methods that we use to measure or calculate the volume of a solid. If it is a regularly shaped object, we can measure its dimensions and then use a formula to calculate it. And I would guess you probably know, I know some of you do because you gave it to me earlier. What is the formula we can use to calculate the volume of a rectangular prism? Sienna? Length times width times height. Correct. So that's the volume of a box or rectangular solid or a rectangular prism. Is that what you call it now in math class?
Rectangular.
Yeah. Is that the word you use?
Yeah, that's what we used last year.
So anyway, we abbreviate that. V equals L times W times H. So when we're solving a problem in science class, we write the formula. What's our next step? Substitute for each variable. Final step. Calculate the answer. What do you give for an answer for this question? What is the volume of that box? Holly?
6 centimeters cubed.
Good. So units. Why did you say 7 meters cubed? Okay, so you just do that? Remember, what you do with numbers, you do with units. Do the units work out to be centimeters cubed if I look at the formula? What does cubed mean? How many?
3 numbers.
Well, not just multiplying 3 numbers. What does cubed mean?
It means like when something is multiplied by itself.
Yeah, something times itself times itself, 3 times. So centimeters times centimeters times centimeters, does that work out to be cubed?
Yes.
Yeah. So the answer is 6 cubic centimeters. We could say centimeters cubed, we say cubic centimeters, either one. So does anyone know the formula for the volume of a cylinder? So have you memorized it? Okay. Because it should make sense. Because what was the so when we were, if we were to take area of a shape and expand it upward, so when we do length times width times height, we find the area, which is length times width, and multiply it by the height. So can you guess how we're going to do it for a cylinder?
Do you have to read out the formula or just?
Yeah, I want the formula.
Okay, I guess it would be V equals diameter times height.
Not quite. Sean?
Volume equals radius squared times 5 times height.
Good. So what was the area of a circle?
Radius times, radius squared times
I times radius squared. So then if we take the area of the circle and multiply it by the height of a circle, we're taking it and making it a three-dimensional shape. So yes, pi times radius squared times height is the formula we use for the volume of a cylinder. Substitute in our numbers. 3.14. Now, what am I giving you in the problem here? The diameter, so we have to divide it in half to get the radius, which is 3. And the height is 8 centimeters. What do we get for an answer to this problem? Abby?
226.1946711.
Scoops of hummus?
Centimeters cubed.
Correct. So we can agree, we can round to the tenths, that'd be fine. 226.1 cubic centimeters. Do the units make sense in the formula? Because I have centimeters squared here. What's centimeters squared times centimeters? Centimeters cubed. So we're back to the operating. Now there are other formulas. There's formulas for the volume of the sphere or pyramid shape. We're not going to get into all those. These are the only two you're going to have to know and use. Okay? Pi r squared times height and length times width times height. Now, that's fine if you have a regularly shaped object. What if you have a liquid? Can I measure the length, width, height of a liquid? Can I just pour this on something? What could I do to measure the volume of a liquid? See it? Yes, although we don't call it a beaker. Does anyone know what this tool is called? It's called a graduated cylinder. Yeah, it's kind of like a beaker with markings. A beaker will have markings on it, but it's just for estimating volumes, not for technically measuring volumes. So, to measure the volume of a liquid, it's pretty simple. We take the liquid we want to measure, we pour it into a graduated cylinder, and then we read what it says. Now, there's some things to keep in mind, however. Whenever you pour water in a tube, it forms a curve. The name of that curve is called the meniscus. So you can see it here. And so the question becomes, well, where should I read the volume? Do I read like the top? Do I read it here? Do I read it here? Do I read it here? Where do I actually look when I'm finding the volume of this liquid? Always read the bottom of the meniscus in the center. So what's the volume of water I have in this graduated cylinder? See hands up and down, up and down. Walker?
12 millimeters? No,
Neither. Close on both, but not perfect. Anyone have a different answer, Abby?
Never mind.
Tyler?
13, whatever it's nebulous.
No. Ella?
11.
No. Well, they're all over the place. Sean?
13 millimeters?
Sorry, I was going Sean there. What? Okay, here we go. Yes. So let's look at this. So one of the things is different graduated cylinders, each line is worth a different value. On a large graduated cylinder, each line may be worth, this one, over here, each line is worth 2.5 milliliters. In this graduated cylinder, the small one, each line is worth 0.2 milliliters. This graduated cylinder, each line is 1 milliliter. So it depends on the graduated cylinder, so you have to kind of look at it. We look at this graduated cylinder, so this 5, what does it go with? Does it go with this?
No.
What's it go with?
The big
This long line. These 5 milliliter markings are the longest ones. Okay, so that's 5, that's 10. How many lines do we have in between? Total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if there's 10 lines between 5 and 10, what's each line worth? 0.5. And it's marked differently. What do these longer lines represent? True?
The whole number.
The whole milliliters. So here's 6, 7, 8, 9, 10. What are the smaller lines? So now? 0.5. So that's 5.5, that's 5, that's 6. 6.57, and so forth. All right, so now when we look at it, so here's 10, 10.5, 11, right at 11.5. This is a volume of 11.5 milliliters. So when we're measuring volume using a graduated cylinder, the unit we typically use is milliliters. How many milliliters in a liter? 1,000. All right. Now for gases are a little weird. For gases, gases expand to take up as much space as you give them. If you have a balloon that's filled with gas, the gas is taking up the volume of the balloon. Once you let it go, the gas expands and takes up more space. You can condense gas a great deal as well. So we're not really going to measure volume of gases. They vary depending on the pressure and the temperature. So the units we typically are going to use in class are either milliliters or centimeters cubed. Now, 1 milliliter, if I take a 1 centimeter by 1 centimeter by 1 centimeter little tiny cube and fill it with water, that's 1 milliliter. A milliliter and a cubic centimeter take up the same amount of space. They're interchangeable. But I will tell you now, you'll have a quiz sometime. And I'm going to tell you what are the questions, but still many of you are going to get this question wrong. The question is going to be 5 cubic centimeters equals how many milliliters? What's the correct answer? 5. What are some people going to say?
15.
Well, some people will say that.
125.
Some people are going to say 120, but they're going to cube the number. But they're not. A milliliter is the same as a cubic centimeter. And also, milliliters are never a cubed unit. They're always just milliliters. All right, so now, well, I know how to calculate the volume of a regular shaped solid, which I have a formula for. I know how to find the volume of a liquid. Well, what if I have a small pig shape? Does anybody know the formula to find the volume of a very small pig? They didn't teach you this formula in elementary school? All right, so how does this pig have volume?
Yeah.
Does it take up space?
Yes.
How much? A lot. A little bit. So how could I determine this?
It's great.
Not quite. If I knew its mass and I knew its density, I could figure out its volume. We'll do that eventually. But for now, we don't know what material it's made out of, so we don't know its density, so we can't do that. Colin?
Make a mold of it, put water in the mold, take the water out of that mold, put it in the beaker, find out.
That's interesting. That would work. I have a simpler way. Colin? Graduated cylinders? All right. If I put some water in a graduated cylinder, then I put this pig in a graduated cylinder, would the water level rise?
Yes.
And the amount it rises would be
The volume of
the volume of the pig. Good. That's called water displacement. That's the water displacement of it. Did you ever, maybe you were at practice yesterday and it was pouring rain, but you still had to practice, you were freezing cold when you got home. So you get home, you're going to take a nice hot bath. Did anyone ever go in the bathtub and fill the bath completely up with water and then get in? No one ever did that? And then what happens? Yeah, it might
Not
be.
good, not good.
Why?
Because everything that you don't want wet is gonna get wet.
Because what happens as you get in?
All the water goes out.
All the water comes out. If you were able to fill the bathtub completely to the very, very top of the water, then you get into the bathtub and you're able to capture all of the overflowing water, pour it into a giant graduated cylinder. What would the volume of that water be?
The volume of you.
The volume of you. It's
Plus maybe a couple extra drops if your solution's full.
maybe, we're trying not to splash. They used to do this in earth science. They used to have one volunteer. They had this big 55-gallon bucket. They filled it with water. They had one volunteer come into school one day in their bathing suit, put themselves in the giant barrel, catch all the water coming out, measure its volume, and then figure out the volume of the person. And we're going to use this little pig instead.
My other idea was to like melt the pig enough, but don't.
So let me ask you a question. This is something else that's going to come up. Let's say I had a cylinder or a rectangular solid. Could I measure its volume using water displacement?
Yeah.
I could. You know which is going to be more accurate? Measuring with a ruler and calculating, or water displacement? Tyler?
Ruler and calculator.
Yeah, you can be much more exact measuring and calculating. So if you ever have a regular object and you have the choice, use the ruler and calculator. But if it's an irregular object and you can't do that, then you use water displacement. So, which of these graduated cylinders should I use?
The medium,
Why the medium?
because it doesn't fit the smallest one and the biggest one.
So I always want to choose the biggest. Should I put it in this?
No.
Why?
So small. You don't even count that X.
Yeah, the water would barely go up. And what about the markings on this? Do you remember what I said they are? 2.5 milliliters. So I can't be that accurate. If I were able to fit it in this one, where each line is 0.2 milliliters, I could be very accurate. However, Wilbur does not fit in there. Wilbur. So, let's try. We should always use, for any object, the smallest graduated cylinder which can hold the object. All right, so let's try this. Should I fill it up here?
Another thing that I found.
Now, this is-
Overflow.
what? That's probably not. But, did I do it correctly? Because already the water level is above the highest marking. So I'm not going to know how much it's going up. So I always start, you need enough water that your object will be submerged, but not so much that it's going to go above the largest number. That's fine. Does it matter how much I use in here, as long as I meet those requirements? No. All right, so right now, I should put it flat. To read the meniscus, you always want to kind of be eye level. All right.
Oh, this is a weird graduated cylinder.
Just graduated, so
Um, There are 18 milliliters right now. 18 milliliters.
Guess what? Right from the Argentina. He's good.
All right, now there are 20 milliliters.
Gonna drown.
What is the volume of Wilbur?
About 2 milliliters.
2 milliliters.
Roughly.
Now, sometimes, there's another way I can do this. So, I've never heard of Archimedes' principle.
Oh, wait. Yes.
I've heard of it, but I have no idea what it means.
Yes.
This is buoyancy.
Yeah.
Archimedes got into his bathtub and water overflowed and he realized well, it doesn't really matter. Go ahead. Yeah, Colin?
I watched a video on YouTube by this guy who's a NASA scientist who worked with the Jet Propulsion Laboratory. His name was Mark Lober, and he did a theory with this. Like, he and his friend put enough Orbeez to fill his pool, and then they got in and saw how much Orbeez were displaced, how far in they would go.
Mhm.
And Mark thought that he would go all the way in, but his friend Kevin thought he would only go halfway through, because they space in between them. So technically, the experiment was invalid because it would just be the same as getting a real one.
Oh, okay. Interesting.
And
All right. Oh, sorry.
No, and then there was another one where it was like,
Is this related to water density and
Yes.
volume? Okay.
and then there's another one where he had like a glass of water and then there's a bunch of ice cubes in it. And then it was like, when this ice melts, will the water become, like, will there be more water in it or will it be the same as glass? And it was the same because the ice is water, so it displaces its weight in water.
Yep.
And then just,
Yeah, when icebergs floating in the water melt, do they cause a rise in sea level?
Yeah.
No, because they're displaced in the water already. Increase in sea level comes when you have ice on land.
that melts off.
That melts, and then that water runs in. But anyway, that's way beyond what we're doing. All right, I can also use this thing. This is called a spill cup. I don't know why it's all. Anyway, it doesn't really matter. It's the out of flatness that it is. But anyway, what you can do if you have a weird object that's just too large to fit in a graduated cylinder, you can. I'll go behind so you guys can see. You can fill up this spill cup all the way till it overflows. All right, so. Sorry, I'm going to use that one.
Anyway.
All right, so now it is completely full. So now, if Wilbur goes swimming, and I capture the water in this graduated cylinder,
Oh, yeah.
what should the volume of the graduated cylinder be?
2 milliliters. Ollie, don't keep Ollie, when you used to be able to drop the over down 1 milliliter graduated cylinder, was it like the Titanic was the same? Yes, yes it was.
All right, that's close enough. Let's see.
Here, let me say it for
2.2 milliliters.
shaking up the
So what do you think is more accurate?
the other one.
Yeah?
Oh,
I don't know. I'm not sure actually myself. Because this one is so out of round and the table
Yeah, that's
is
what I was
going
saying.
well. But they were pretty close, and that's what we'd expect.
And also the table was shaking pretty badly on the.
All right.
You're 2 bells, isn't it?
Oh,
Whoa!
did it all
That
come
was
from there?
super satisfying.
All right. We'll have to wait for the YouTube videos.
Yeah.
All right, here, let's see. We all did that. That's how we do water displacement. So if I have 55 milliliters of water, I add a small rock. Read the volume at 63 milliliters. What's the volume of the rock?
63
Not the rock, but the rock. 8 milliliters.
Mr. Budos, is there a reason why Wilbur's turning the water thing? Poor manufacturing.
He dies is for.
It's a dog all along. What do you fly?
I don't know. It's weird. I don't know where rubber came from, but it's like anatomically correct. It's got
What?
like nipples for nursing a little tiny tiny pig in there. It's kind of weird, but hey, I guess it's a science thing. Too much information.
Anything past the Yes.
Let's take you pop the pin.
What's the name of that scientific study you're using the water?
Graduate cylinder, spill cup.
Spill.
Okay, this is your homework. Lucky for you, you still have 7 minutes which to work on it to finish a significant chunk. Because you know I'm going to ask your parents tonight if you're home working on your homework. Are we going to see many of your parents?
Yeah.
Yep. There is a back.
There is. There's always a back.
Oh yeah, Ollie. No, don't worry, guys. Don't worry. Oh, don't worry. My mom doesn't care about
notice there's a bag over there.